Hello everyone. In this video we are going to discuss vector or cross product. Now by vector product or cross product of two vectors, it means that the two vectors are multiplied in a specific way in which the result also is a vector quantity. We have seen that in vector multiplication there are two different ways in which two vectors can be multiplied. One is the dot product, which is also known as scalar product because the result is a scalar quantity. And another is the vector product or the cross product, which we are going to discuss now. The result will be a vector quantity. Now let us see what vector or cross product is. The vector or cross product of two vectors is defined as the vector whose magnitude is equal to the product of the magnitude of the two vectors and sine of the angle between them, and whose direction is perpendicular to the plane of the two vectors and is given by right hand rule. Now you need to understand here a few things very carefully. Let me show you the diagram first, and then I will explain it again. Diagram I will discuss in the next slide, but here you see two vectors we are considering, vector A and vector B. So according to the definition here, the cross product will be a vector quantity whose magnitude is equal to the product of the magnitude of the two vectors. That is, suppose vector A cross vector B we are considering. So vector A cross vector B will be given by the product of magnitude of A and magnitude of B and sine of the angle between vector A and vector B. So here you can see the vector which we are considering here, A cross B, the magnitude of the vector is given by, you can see here, this is the magnitude of the vector, which is given by AB sine theta. It doesn't have any direction, but it is multiplied by a unit vector here, which is given by n cap. Unit vector represents a vector which has unit magnitude and its direction is perpendicular to the plane of vector A and vector B. That means in whatever plane we are having vector A and vector B, the direction of A cross B, which is given by n cap, will be the direction which is perpendicular to the plane of vector A and vector B. And that particular direction can be given by right hand rule. There are two rules, right hand thumb rule and right hand screw rule, that we will discuss. I will enlarge the window here and I will show you what exactly I mean. Suppose you take a plane here. Suppose this is the plane. Now in this plane, if you have two vectors, that is vector A and vector B, then the result will be given by a vector in the direction perpendicular to this plane. Now the perpendicular to this plane can be in the upward direction, it can be in the downward direction also. But which direction, whether it is upward or downward, it will be given by the rule which we are going to discuss now. So I hope this is clear to you. So what we can consider here now is that a vector is there, A, another vector is B, their cross product is AB sine theta n cap, where n cap is a unit vector which is perpendicular to the plane of vector A and vector B. Now let us see the perpendicular to the plane of vector A and vector B. So there are two possible, whenever we consider a plane, then there are two possible directions of perpendiculars. Now which direction has to be considered? We have rules for it. The first rule which we are going to discuss here is right-handed screw rule. By right-hand screw rule, we mean that the vector A and vector B are taken in a plane as shown here, and we are going to find the direction of A cross B. Because A cross B is given by AB sine theta, the magnitude is AB sine theta into n cap. The direction of n cap actually gives the direction of A cross B. Now whichsoever plane we can see here a plane. You can see the plane here which is drawn here. Now in this plane there are two possible directions, perpendicular direction. One in the upward direction, another in the downward direction. So which direction we need to consider, that will be decided by the right hand screw rule. As shown in the figure, if the right-handed screw is placed with its axis perpendicular to the plane of the vector A and vector B and is rotated from A to B through the smaller angle, this you should understand, through the smaller angle, then the direction in which the screw advances give the direction of A cross B. First of all, you need to understand what is right-handed screw. Right-handed screw is any screw which you use by your right hand, whether it is the way you rotate the tape, or you rotate the cork of a bottle or the cap of a pen. So all these are right-handed screws. Okay, so you have to take a right-handed screw, and then that right-handed screw which you will take, you have to place it perpendicularly to the plane where vector A and vector B is there, and then you have to rotate it from vector A to vector B, because we have to find the direction of A cross B. So to find the direction of vector A cross vector B, we have to rotate the right-handed screw from A to B along the smaller angle, because there is another possible angle, the greater one, which we don't have to consider. We have to consider the smaller angle only. So if we consider the smaller angle and if we rotate it as shown in the adjacent figure here, we will find that the right hand screw will move in this direction, in the direction as shown here, which will be the direction of A cross B. Naturally, if you want to find the direction of B cross A, so you will rotate the right-handed screw in the opposite direction, and the screw will move in the downward direction, which gives the direction of B cross A. So you need to remember one thing here. A cross B, the magnitude is AB sine theta. B cross A, the magnitude will be BA sine theta, which is same, but the directions are opposite. A cross B is in the upward direction and B cross A in the downward direction. So if we want to write the vectors A cross B, so if we write here vector A cross vector B, so in that case, if we want to write it equal to vector B cross vector A, their magnitudes are equal, but if we write it in this way, then it is wrong. We cannot write this because their magnitudes are same. We can use a modulus sign in both the sides, then it becomes equal. Otherwise we have to consider a negative sign, which shows that A cross B and B cross A are in the opposite directions. Okay, so this is one particular rule to find the direction of the cross product of two vectors. Another possible rule is there, that is right hand thumb rule. That is again very important rule. As shown in the figure, if we take the curl of the fingers of the right hand in such a way that they point in the direction of rotation of vector from A to B through the smaller angle, then the stretched thumb points in the direction of A cross B. You have to take the right hand and you have to consider the curved fingers. This curved fingers will give you the direction of rotation. The thumb will give you the direction of the cross product. Like again, you have to take the smaller angle from A to B. It is A cross B, and you have to take the smaller angle here. So when you take the smaller angle here, you find that the vector is rotated from for A cross B, we have to move from A to B. That means the thumb, the curved fingers, the four of the fingers are there, little finger, then ring finger, middle finger and forefinger. They will take the curve from A to B. Then the thumb will give you the direction of A cross B. Similarly, B cross A, you have to take it in the downward direction. So B cross A is in the downward direction. Okay. So I hope this is very clear to you. So we move to the next part now. Now vector product of orthogonal unit vectors. By orthogonal unit vectors, we simply write it as unit vector also. So when we take unit vectors, see, the vector product of the orthogonal unit vector, it is the magnitude of each of the vectors I cap, j cap and k cap is 1. We all know that the magnitude is 1 and they have an angle of 90 degree between them. So when we take the cross product, suppose we take the cross product of I and j, that is I cap cross j cap. So the formula is A cross B, we write AB sine theta. So here it is 1 into 1, because one is the magnitude of I cap and another one is the magnitude of j cap also. They are the unit vectors. And the angle between them is 90 degrees. So sine 90 is 1 and n cap. So 1 into sine 90 is 1. So we have 1 only. So we are just left out with n cap. So I cap cross j cap, we'll get a unit vector which is perpendicular to both I cap and j cap. And by using right hand thumb rule or right-handed screw rule, the direction is along positive z-axis. So n cap is in the positive z-axis direction. So in the positive z-axis direction, the unit vector n cap can be represented as k cap. So that's why we write I cap cross j cap is equal to k cap. I hope this is clear to you. So if this is the case, then I cap cross j cap is written as k cap, as we have just now explained. In the same way, you can find out j cap cross k cap. It will be represented as I cap, and k cap cross I cap will be j cap. Now, I have just told you earlier that A cross B is equal to minus B cross A. So I cross j we have written as k cap. So j cross I will naturally be minus k cap. Similarly, k cross j, since j cross k is I cap, so k cap cross j cap will be minus I cap, and similarly I cap cross k cap is minus j cap. So there is a very easy way of representing or remembering this. You have to take a cycle. In this cycle, you write in the clockwise direction I cap, j cap and k cap. And whenever you traverse it in the clockwise direction, you will always get a positive value. That means I cap cross j cap is k cap, j cap cross k cap is I cap, k cap cross I cap is j cap. And when you traverses in the reverse direction, that is j cap cross I cap is minus k cap, I cap cross k cap is minus j cap, and k cap cross j cap is minus I cap. So I hope this is very clear to you. You, instead of remembering all this thing, you can just remember the curve cycle here, and accordingly you can easily give the values. Now the one last point I want to discuss over here, and that point is, like when we take the cross product of the same unit vector, that is I cap cross I cap. So we have the value, the angle between them is 0 degrees. So 1 into sine 0 n cap. Now sine 0 is 0. So the whole term here becomes 0. So I cap cross j cap, then j cap cross k cap, and k cap cross k cap. So I, j, and k cap, their cross product is always a null vector, which is given by 0. So always remember, it is just opposite to which we have seen in scalar product or dot product. The dot product of I cap dot I cap, j cap dot j cap, and k cap dot k cap was 1. But here I cap cross I cap, j cap cross j cap, and k cap cross k cap is 0. So I hope this is very clear to you. Any doubt, you can post me the doubt. Thank you.